another episode of Ms. McIntosh's Music. Today's lesson is our music experiment number 3. We've done a lot on our music experiments all about vibrations and making sound, but today's lesson is all about seeing sound and also figuring out how we interpret sound using our ears. So up next, you're going to see a little bit of a video about how our ears work. Then we're going to get into the experiment and we're going to be making something that helps you see sound. Here we go.
The ears collect sounds and turn them into messages for the brain to interpret. They also send information about balance to the brain. 3 sections of the ear work together to make this happen. They are the outer ear, the middle ear, and the inner ear. The outer ear is made up of the pinna and the ear canal. These parts gather sounds from the environment and funnel them into the middle ear. The middle ear takes these sounds and turns them into vibrations. Sounds that come into the middle ear hit the eardrum, causing it to move. The eustachian tube helps the eardrum to work well by keeping the air pressure balanced on both sides. When the eardrum moves, it makes 3 small bones, called ossicles, vibrate. The vibrations are then sent to the inner ear. The inner ear receives vibrations and changes them into messages that go to the brain. These messages are called nerve signals. The inner ear is made up of the cochlea and the vestibule, which includes the semicircular canals. The cochlea has fluid in it that moves like a wave. This happens when vibrations come in from the middle ear. The moving fluid causes hair cells to make nerve signals about sound. Semicircular canals also use moving fluid to create nerve signals that help with balance. Then, the signals from the cochlea travel along the auditory nerve. Signals from the semicircular canals go along the vestibular nerve. These 2 nerves come together and lead to the brain. There, the brain decodes the signals to get information about sound and balance.
All right, so the things that you will need for your experiment is a little bit more than our last experiment. You will require toilet paper rolls or 1 paper towel roll, tape, scissors, cornstarch. So you can't use substitute flour for this. It has to be cornstarch. Water, a balloon or plastic wrap, or if you have a rubber glove, anything that's kind of stretchy like that. A mixing bowl and an elastic band. So I'll hold this up here so you can look at all the things you need, and then we'll get to the experiment. Okay, so now we have everything that's needed for the experiment. So let's get started. We're gonna start off with the paper towel rolls / toilet paper rolls. It's up to you what you end up using. You might even want to use both. I forgot to mention, if you want to decorate your science project before you do anything else I'm going to show you, color the paper towel rolls or toilet paper rolls, and then you can do the experiment. So if you're using a paper towel roll, you're going to want to cut 2 diagonals. So a diagonal here and a diagonal there. And the reason being is because when you create this, you want to be able to see the sound at the same time as you're making the sound. Okay, so when you cut it, you can kind of put them into a U shape, so you'll be able to see the sound. But it's sort of up to you however you want to shape it. So I'm going to use some tape. Oops. I'm going to take this tape and tape this all up, and I'll show you what it looks like after. I won't make you watch me make it. All right, guys and gals, I have now made my tube here. I made my U shape, so you can see the U shape, but then I also added a toilet paper roll on because I wanted it to be a little bit longer. It's up to you how you want it to look, but all you want to make sure is that you've taped all of these holes really well and that the sound goes all the way through. So you can test it by making a sound in the sound hole and put your hand on the other hole, and if you can feel the air coming through and touching your hand, then you've done a good job at taping it. So like this. And I can feel it on the palm of my hand, so we're good to go. Okay, let's move on to the next part. We are going to make our cornstarch and water substance. Now, you may have heard before that cornstarch and water is called oobleck, but the proper scientific term for when you put cornstarch and water, and this is a fancy term, so it makes you sound super smart, is a non-Newtonian substance. So this is saying that cornstarch and water doesn't follow Newton's laws, so it's non-Newtonian. So I've already added 1 tablespoon of cornstarch in my bowl, but I'm actually gonna add 2 tablespoons. And then I'm going to do 1 tablespoon of water. So the ratio is 2 to 1. So if I did 4 tablespoons of cornstarch, I would do 2 tablespoons of water. So once I've added it in, this is the part where it gets tricky to mix. When you mix cornstarch and water, it turns into a solid when you mix really hard, and then it feels like it's not mixing. So I'm gonna turn it down like this so you can see. So you have to be kind of gentle about it to get the water to mix in. And I'm actually gonna add just a teensy bit more water to this because I think 1 of my tablespoons was a little too large. I'm gonna add a bit of water. And then when you mix it together, you'll see it's kind of hard for my spoon, like I'm pushing really hard. And it's because this substance is a solid when you apply force to it, but it's a liquid when you just let it drip. So if I put this, see how it's solid on my spoon? And then if I pour it, it turns into a liquid. So it's really, really cool. So that in and of itself, it's fun to play with. And the best part about it is that it's not super messy. So you'll be able to feel it. You'll feel how hard it is. You can also test it out by really like pushing your finger against it, and you can feel it go hard against your hand. Like if you press really hard, see how it's not coming off on my finger? But if I go slowly, then suddenly my finger's drippy. But if I go hard, it's not coming off. So that's a non-Newtonian substance, which is really cool and scientific. Okay, so now we've made our ear canal. We've made our non-Newtonian substance. Now it's time to create the eardrum. So this is when it comes to your balloon, your glove that you're using, maybe it's plastic wrap, it's up to you, but something that kind of needs to have a little bit of flexibility to it. So I'm gonna use a balloon for this. I'm gonna blow it up a bit just to get some flexibility into the balloon. And then I'm gonna cut off this bottom part of the balloon. So here we go. Let's make some vibrations. Excuse you! All right, chop this off. And I'm going to put this on the shorter end of my ear canal. I'm gonna wrap it on. Now, if you're using something like a glove or plastic wrap, this is where your elastic band will come in. And I'm noticing that this balloon actually kind of has a little bit of a dent in it, so I'm going to try to stretch it out a bit more. And then I'm going to put it back on, grab my elastic band, and make it tight, just like that. Okay? So now you have something flexible on the end, you have your sound hole, and now it's time to try the experiment. Yay! I had to change rooms. Mr. McIntosh is on a conference call and I can't yell, but you'll see why at the end of this experiment. So I changed the color of the balloon up here just so you guys can see the experiment a little bit better. But you'll notice the top of my experiment is tight like a drum. So it's kind of, this is the eardrum, this is the ear canal. So before I show you how to complete the experiment and see sound, I just want to explain why this works. Okay, so if you were to wave your hands around you right now, you can feel resistance. You can feel the air around you. And that's because air molecules are always around us. So anytime something makes a sound, whether you're slamming a door, it's your voice, maybe it's coming from a device, air molecules are being moved. And those air molecules copy the sound cycles, and those sound cycles, those moved air molecules, are what is coming into your ear and what your ear is processing. The sound cycles need to be processed through your ear so it can send signals to your brain so then you can understand what you're hearing. So our thing here represents the air molecules or the sound cycles that are going through our inner ear to our eardrum, and then the non-Newtonian substance, our solid and liquid substance here, represents the fluid that's in your inner ear. So what we're gonna do is we're gonna take a teensy little bit of it and let it drip on top. And I do mean a small amount, because if you put too much, it's gonna drip over the sides and then it just makes a mess. So just a little bit. And if you want to double check if it's still a liquid and a solid, you can press really hard and you'll see it's still a solid, but then if you don't press on it, it'll start dripping as a liquid. Okay, so I'm going to tilt this down so you can see sound. I'm going to make the air molecules go through my inner ear, and I want you to see how our liquid in our inner ear is received from the eardrum. Let's see. Okay.
Woo! Woo! Woo!
All right. Have fun making this at home. It's a great way to annoy your brothers and sisters and parents. Enjoy the experiment and let me know how it goes. Have fun.